Good day, doctor. My name is Beh Huey Siang and my metric number is 285626. So, in this video, I would like to present about what I have learned based on the two articles that I had read before. So, these two articles are related to the trade safety. So, first of all, what is track safety? Track safety is referred to one of the characteristics of the software system or applications that ensure the correct behavior when people execute multiple threads concurrently. So track safety is essential when it ensure because it ensures that program run correctly and consistently in a parallel environment when creating a concurrent or multi-thread software system. So we can say that the program is track safe if multiple threads can use it without synchronizations, and if the behavior observed by each thread is equivalent to linearizations of all call that maintain the order of call in each thread. So, and if the thread means if track safe means that all its methods are track safe. So the reason that we need to detect a track safety is to avoid issue or problems that may occur from multiple thread accessing and modifying shared data simultaneously, such as the data corruptions, unexpected behavior, and bug such as a timing bug that show by the first articles. And also, unfortunately, the current technique are basically are not full automatic. So based on these two articles, okay, are trying to propose an automatic testing approach or technique that can track and prevent concurrent bug in supposedly track safety class or program. So for the second article, the technique is track safety violations detector, which is TSVD, one of the track safety testing techniques. Next, for the first article that I had read is the fully automatic and precise detections of the track safety violations. So the problem statement of this article is the challenge of ensuring track safety in a Java program where the concurrent executions can expose problems that are difficult to find. So the objective of this article is to develop an automatic testing technique that only need a minimal human effort to detect and with just few test cases without any manual specifications to detect the track safety and the bug in the concurrent program. So the method of this article that used is it contains two components, which is the generate test and oracle test, which is used to report bug when a concurrent test is executions result in the exception and or deadlock that cannot be resolved in any streamline, and the exercising track safety class from multiple thread. And the result of this article is it analyzed 6 popular Java libraries, and it successfully found 15 defects in supposedly track safety class, and 2 of the defects are previously undiscovered in the Java standard library, and this is the approach that reveals most bugs without any requirement on the analysis class, which such as the throwing exception if an unsafe state is reached. And the conclusion of this article is the proposed approach is effective in automatically detecting the and identifying the track safety problem in the Java class, and it also successful in minimal human effort and produce a true positive bug report in the process of the detecting track safety problems in Java program. For the second article that I had read is efficient scalable track safety violations detections, and the problem statement that this article show is the difficulty of finding track safety violation in complex multi-thread and asynchronous programming model that used in the .NET program. So the objective is to present the track safety violations detector technique, which is the TSVD. Okay, and it deal with complex multiple threading and asynchronous programming by using several synchronized approach. So the method that this article use is that I have presented about before is the track safety violation detector, and which it utilized an active testing approach with the resource cautions, delay injections, and to detect the possible track safety violations, and it involves injection delay probabilistically, and use approach like happen before inference and near miss tracking. So the result that shown by this article is can say that TSVD is effective in detecting track safety violations, and the finding show that in terms of bug detection rate, overhead, and the impact of the varying parameters. So and also this article is suggest that TSVD is a approach that can enhance the reliability of the multi-thread applications. Okay, and in the conclusion that according to this article, it can conclude that the TSVD that I say is indicate that this article say is indicate its effectiveness in detecting bug with within the reasonable overhead. Okay, for the last part, which is what the thing that I learned from these two article. Okay, the thing that I learned from these two article is the approach that they use in detecting the bugs, and how to determine that the track safe class in concurrent program or in Java program. So I have learned for the first article, I had learned about the automatic technique, which is have two components, which is generate test that concurrently exercise track safety class, and the oracle, which is used to identify bug when concurrent test is executions lead to the exceptions or the deadlock that cannot occur during any linearized text executions. And then I also learned about the detail of the approach, which is like the underlying concept, definitions, and the role of the track safety oracles. And then for the second article, which is the approach that they use is the track safety violations detections technique, which is TSVD, and I learned about how it works, which is by setting up the program and using the resources cautions, which is the resources aware delay injections approach, and it is integrated into the development and test environment, and provide the efficient way to detect the bug without false positive. Yeah. And then the approach is designed to detect and identify the concurrent bug, especially for the track safety violations in the .NET program. Okay, based on the second article.